أنا إذا كان أنا project. لا okay. They just I'll do one last. Okay,
ladies and gentlemen, glad you guys are back in the snacks. My name is Faisal Ahmed-Wali, and I'm here, and it's an honor for me to represent Hydromet at this HydrometAFRICA event, along with two of my colleagues, Thomas Weber and Jean-Philippe Batin, who are sitting here. So let me go through first as to.
Yeah. 1 second, is this not doing? Bear with. We just tested this and it was fine. So.
As to who is HydrometAFRICA is a multinational manufacturer of hydromet. We are a group of brands. Okay, so I'll focus on the brands which are active in Africa. We have Kip and Zonin, world renowned for solar radiant and sensors, many of which are used in many of your weather stations today, whether they're supplied from us or other manufacturers. Luft, a company based in Germany, a brand based in Germany, where we manufacture weather sensors, so wind sensors and all-in-one weather sensors. We have Sutron, well known for data loggers and telemetry. Factory is based in the US, in Sterling, Virginia. OTT, very well known for hydrological sensors, based in Germany, in Kempten. We have ADCON, which is installed in many of the African countries for weather stations or weather monitoring. And finally, HydroLab. HydroLab, our factory based in the US, which is mainly water quality monitoring. So we manufacture multi-parameter water quality sensors for surface water and groundwater. Okay, so just to be clear, we are not distributors of these brands. We own these companies. This is all of these brands here are part of Hydromet. And the way we operate in Africa, some very little African countries, we work direct with government agencies, but in most of Africa, we work through channel partners or system integrators such as Warta. Now, our portfolio we cover the water cycle. So if you're looking at weather, surface water, groundwater, ocean water, rainfall stations, outdoor weather, this is where we are active. This is where we offer our expertise. Now, looking at the slide here, so our products support the objectives of various global and WMO initiatives, some of which are listed on the slide. So, why are we here today? Speaking to our customers now, I've been in this industry for 15 to 17 years. I've worked in Africa, Middle East, and Caribbean. Many of our customers, when you speak to them, have problems. So the problem statement that we have here is, as government agencies, my network is installed in areas that are spread over an area where there is no cell network, so no GPRS or GSM network. My local network in some areas is patchy. You may have areas in your country where you have strong cell network, but you have others where there is no network. And this is maybe more relevant in hydro rather than weather. Due to budget constraints and delays in procedures in governments, they tend to have delays in paying their cell network. So what you start to see is your stations go down and you miss data. So the solution, you need a telemetry device that is all over Africa, one that is free to the Hydromet services, one that has a high rate of transmission, success rate, one that is able to integrate to your existing databases, whether it is from Opt or other manufacturers. And finally, one that is redundant, a solution where not only can I have HydrometAFRICA, but perhaps you need redundancy in your telemetry. And the answer is HydrometAFRICA. HydrometAFRICA offers you all of those. HydrometAFRICA is free with every single Hydromet service in this room here. It gives you that 1 hour transmission. You can measure your data every 10 minutes, combine it, push it out every hour. HydrometAFRICA gives you redundancy. It stores your data on the portal for 14 days. And finally, HydrometAFRICA gives you, as I said, a 1 hour transmission, but they also have a alert channel for warnings. And how can we support? This year is our Sapling 3. This has been in existence for the past 20 years or more. This is our 3rd generation sapling. It is a data logger with internally HydrometAFRICA translator. But it also has redundancy. Not only can you have HydrometAFRICA, you can also add GPRS and you can add the medium satellite. So you can have 3 modes of telemetry in the worst cases. This Sapling 3 is installed and used by NBI for their HydrometAFRICA network. We have done this in Namibia for their hypo stations. Many of these saplings are used in hypo stations in Africa, both level. It is sensor independent, so you can use any other sensor that you have. The Department of Water Affairs in South Africa, they are using these saplings for their hydrological monitoring network using existing sensors. So this is our solution to helping you with your issues with gaps in your data in locations with no GPS technology. So it's very short. This is where we offer value, and this is where we can support you. Now, there's one more point I want to make. We have done a lot of work in Africa, and we travel a lot into Africa. We're in many countries. We're on the roads twice, maybe 2 weeks out of the month. And we want to focus on sustainability. We are here to support you. Please, if you have our equipment and you are in need of support training, let us know. We are in your countries. It doesn't hurt for us to sit down with you for 1 hour, 2 hours. Just give you some refresh training. That's how we can support you to ensure your networks are sustainable. So not only do we want to supply the equipment either direct or through our channel partners or system integrators, but we want to support you in ensuring that your equipment is working and that your engineers and your staff are trained. So we are here in the booth, 3 of us are here. If you have our equipment, come to us. We can help you with training and let us know how we can support you. Because if the equipment fails, you fail and we fail. And we don't want that for you. Thank you very much.
Many thanks, Faisal. If there are any questions, Faisal, please do go to the stand. They're here for the next 2 days. And next up, Lorraine for Mitri. I have an answer, but
You can join me. Just 1 second. Oh, a minute. There you go.
Everybody hear me okay? Oh, okay, sure.
There you go. You can move around.
Thank you. Hi, my name is Lorraine Ty, and I'm the Director of Earth Sciences Solutions at Esri Inc. in California. So it was quite a journey to get here. But I have to say, after yesterday, it was very well worth it, and I'm very excited to be here. In my role, I oversee what we're doing in earth sciences, where meteorology is one of the disciplines within that space. And we travel the globe to increase awareness of our meteorology applications. And basically, we are a software company, and the software is called ArcGIS, and it links people, data, and science to provide insightful information to improve data decisions. With respect to HydrometAFRICA workflows, we work with a lot of agencies at the national government side, as well as local. So going from local scales all the way to regional and then national. And providing a way to link data, people, and science to be able to understand what's going on in the meteorology space. To examples, recent ones at a national scale with NASA's camera models, NOAA's camera model, so climate resiliency, mitigation and adaptation, as well as UK Met climate data portal. And basically, we've heard a lot over the last few days, or yesterday and even today, about data access. That's one of the things that we see that is most needed by our users, is the ability to have access to the data so that they can perform their analysis, incorporate their observations, and then derive solutions to understand disaster and flooding. And so the ability to have an infrastructure to do that is what our software provides the end user. And it is an interoperable, scalable system. So it works and meets you where you are. It's not required that you have just all of our technology. It works with open source, whatever you have in place, really to ensure that wherever you are, we can help extend, collaborate with you and improve and work together to get solutions. Because as we all know, with respect to flooding and meteorology, extreme weather events, speed is something that we need to go forward with. So building on what we already have is very important. I have a few other slides here that just give you some examples of resources available. So we do a lot in terms of capacity building, so providing complementary training with our software that allows users to understand how to do some meteorology analysis, modeling, how to serve data, how to disseminate it, how to collaborate with each other, how to get your in situ data coupled with remotely sensed data to make better decisions. And this applied meteorology webinar series covers all the pillars that I heard about yesterday in terms of data and data management, observations, forecasting and prediction, as well as community building and working with communities to be able to get warnings out to those users. Also, it's a 5-part webinar series. There's another one on hydrology, so I'm incorporating your drainage networks and source data to sort of like what we talked yesterday when we heard about impact information coming into modeling. The ability to do that within the software is in one of the webinar series within this series to give you an example of that as well. And then the last one is on reaching the community with warnings, all the way to cell phones, media, TV, that sort of thing. And so all of these components within this webinar series really speaks to all the things that we talked about yesterday. And then finally, we have also within that's also a way to build data. This QR code can get you to this African Geo portal, and really it's a digital twin, well, the start of a digital twin. There's many different definitions of digital twin, but basically for bringing together geospatial data, all the way from user to satellites, and making it accessible to many to be able to start to perform your analysis. And this is ongoing, and it's built on our ArcGIS Hub technology, as well as bringing in APIs and open source code to be able to derive solutions for the end user. So you can check this out as well. So I am here the rest of today and tomorrow. If anybody has any questions, please come and see me over there, or you can reach me today. Very easy to find me in my red sweater. Thank you very much for your time.
Yeah, I'm sorry. Next up is our Yabba.
Stick listening.
Yep. Do you want the do you want the clicker?
No.
No, you're fine. Okay. Do you want that?
This one is okay.
Yeah, just
You
press
might
the
have to
button.
set it on.
Good afternoon, Ari David, tomorrow IO, and, just like to say that ArcGIS is great. We love this application because it's so multi-source from the front, from the back. That's what makes, this work, really fun, is to be able to just, make the best out of data. Let me introduce or reintroduce Tomorrow IO. We were here 2 years ago for the last symposium. But we've been hard at work, and I think it deserves an update specifically as it relates to the space program, which is really unique and excites us every day, myself included. But yeah, the company is on the younger side. We've been around for 8 years and have been on a growth path, both in terms of sort of customer acquisition, but more importantly, in terms of technology investment. And this is really all across the value chain, from observations to forecasts and of course into dissemination. So I'll highlight the space part on the observation side. But before I do, I think it's important to relate to Africa and what we're doing here. It's sort of in the company ethos to make value available quickly from the things that we're developing. And in Africa, we're working with Tomorrow Now. It's tomorrownow.org. It's a sister organization. It's a nonprofit, an NGO. And we're essentially connecting agricultural interests with all of this technological development. And more importantly, we're delivering services as part of the partnership to now 6 million smallholder farmers in East Africa, and with the goal of continuing to partner with national Met offices and others to reach as many of them as possible with climate smart advisories. We also engage with the national Met offices to help delineate between what end user services are value added services and therefore should be provided to end users at a price, and what services are part of public good and can be subsidized with that. So we engage very thoroughly with the national Met offices. So a bit about the motivation for the space program. I think it's been discussed almost in every presentation so far that we just get the precipitation rate. And there's not like one right way to do it, but first everyone agrees that this is the primary thing that drives a lot of the multi-hazard impact-based forecasting and alerting. And of course, radar is a key sensor, but in a remote sense, to do that and do that at scale and regionally and globally. So the Tomorrow IO constellation is in the it's in the space part of what forecasters use. Satellite data is used when ground radars aren't there. So we are building a constellation of low Earth orbit satellites equipped with active radar and passive microwave sounders, with the goal of essentially providing a measurement, not an estimate, but a measurement of rainfall globally every 1 hour. So we've now gone through a couple of successful launches, and we're looking to complete this, the deployment part of our work within the next year and a half, 2 maximum. So lots of technical detail that I would be happy to answer while at the booth or during the networking time. Let me just speak about why it's not just active radar, but also passive radar. It's actually important to numerical weather prediction, to modeling, to have these soundings. Basically, it's like a camera with a very wide swath that is picking up microwave data. It has a great impact on improvement of forecast models. So, at the regional level, national level, and of course global level, the value of that part of the constellation is quite large. So together, we're really creating a supportive system of observation for monitoring, for forecasting at various timescales for various hazards, both the active and the passive part kind of coming together and allowing national Met offices and global organizations to really come up with early warning content that is accurate or as accurate as possible. As I mentioned, we've gone through a couple of launches already successfully. So this is in effect on orbit and operating, and there's going to be more launch announcements in a few weeks. I only have time to show one case study. This is over Africa. So this is an overpass over like the central part, and of course, you can kind of tell that this is well, there's probably a dearth of observations in this region. In terms of ground observations. So what you're seeing in the graph there is kind of like an X-ray of the storm vertically, and you can see at about 5 kilometer height. There's really intense rainfall in certain areas, and that's scanned all the way through. So this is going to be in 3 dimensions, again, available everywhere, every 1 hour, and we're validating all of this. Not just with NOAA and such, but of course, here in situ. So we have a program, we have astrometers out, we're measuring raindrops. So this is very much a scientifically founded type approach. So to sum up, this year is going to be really exciting for a number of reasons for us. Primarily because we're really keen on engaging with the end users and getting this information to forecast modelers through building data assimilation schemes. The nowcasting suite of products that can be leveraged in early warning is already quite advanced with machine learning techniques. But this data just adds a lot to it. And finally, we're launching a data service. It's actually already launched, but it's the data that's there is for research purposes. So, but it is available, and those who are interested in it will see me. Basically, this is a service that will gradually shift from a research to operational type data, where the frequency of the refresh rates will, get to 12 hours, then 6 hours, and eventually an hour or less. So that's all I have to share, given the time that I have. But we're really, really thankful to be part of all of this, and we're all in the same boat.
Many thanks, Aaron. And now we have Luca Bobo from Soma.
Yes, please.
No, you don't be confined to your computer. I just want to make sure. I just want to make sure the video will work. Because then we are now. So I will use the video and it's not really working. If you don't mind.
Okay.
It is like I thought that might happen.
No problem. Okay.
Okay, I think this works now. So first of all, hello everyone. I'm Luca Bobo, working for Soma. We are from Austria. And actually today I can promise you 2 things. I will show you something really interesting, really useful, which will make the difference in early flood warning detection. And the second one, I will keep it shorter because I know everyone is getting hungry, you want to get food. So I will keep it short as much as possible, but my booth is over there, so please come over there and we'll answer to many questions as much as you want, okay? So as I just said, we are from Austria. We are specializing in unique and cutting-edge technology, sensor for monitoring snow, ice, which I know is not maybe a big topic here in Africa, even you have Lesotho here, you have snow. And actually today, what I want to focus is actually non-contact flow meter for your rivers. So when the founder of the company, Mr. Wolfram Sommer, more than 20 years ago, brought this technology in the world, non-contact technology, the idea was to bring something without maintenance. I do remember 2 years ago, I was here, there was this lady in charge of the meteorological agency in Malawi. She was throwing number about many stations without maintenance, not providing data, being vandalized. So what about to use like as I said, as I call it, a maintenance-free technology, where as you can see, doesn't matter the high turbidity in the river, if you have high flow, low flow, super easy to install, and you will get data during drought, so for water management, because we know in this day or yesterday, we speak a lot about flood, but also, you know, due to climate change, is that a problem, drought? If we do not have reliable and accurate data, how we can manage correctly the water in our countries, in the river basin? So how it works, the sensor is a radar-based sensor. You see on your left side, so it's emitting basically beam, and we are measuring water level, velocity, and flow. So probably in some of your network, you have already water level. That's the next step. We do not need rating curves. We do not need calibration. And especially, you will see some other picture later on. Is it also not working my computer now? Let's see. Sorry. Oh, that's part of being on the field, I guess, right? Let's play like that. So, you know, like that's a typical example. You can see actually, well, all the videos are from YouTube, so you can have a look later on your office. You can see a trees going down. Doesn't matter if you have a rocks or even a truck, drag it down during the flood. The sensor is out. You can install it on a bridge, on a cable, on an arm. So maximum flexibility where you want to install it, because not everywhere you have a bridge where to install it, right? And you will have, again, I want to underline, you will have data, real-time data, 24/7, even during this type of condition. As you can see, it's really high speed. Inside of the sensor, there is an advanced hydraulic model made by us. As I said, we brought this idea in the world like almost 25 years ago. So we've been installing sensor in Asia, Africa, Europe, North America, South America. So, you know, small river, big river, medium-sized river, and the hydraulic model is flexible for that. But I really like this because it's made by NOAA. So I think a lot of people knows NOAA in this room. So on the bottom left corner, this is the link to the article, to the scientific article and the research that they made using our sensors. So you can see here, here my mouse, so you can see here in red, this is the water level, okay? And in blue, you can see this is the velocity detected by our sensor. So what they discovered, they were surprised to actually discover this, with our sensor, they were able to detect the flood coming earlier. So I would like to ask you, in that case, was 1 hour. How many things you can do in 1 hour? I do remember was the lady, I think his name was Elizabeth. Like how to alert population 1 hour is a lot of time. We have some cases where I personally work in Central America, where they have this informal settlement installed near to the riverbank. And then there is this flash flood coming and then people die. So what about if you connect the sensor with a siren? So when the people heard the noise, then they go away. Or we have some other project where the end user is sending the alert via Twitter. So, you know, nowadays everyone is having a smartphone in his pocket, or almost everyone. So what about, as I said, it could be 1 hour in some cases, some river basin 30 minutes, could be different a little bit. But, you know, my point is, like just even like 15 minutes, this could make the difference to save life, infrastructure, hydropower dams, and cities. So right now I told you, okay, it's cool, it's free maintenance. So you pay one time, you install it, you don't have to invest more money on it. But what about Africa is a good example, but I can tell you also, even in Europe, we have vandalism problem. What about if someone, because it's battery powered, maybe solar powered, I think also in your country, people first thing they steal is the solar panel. Is that true? So what about if you have an equipment with inside the battery, so everything really compact with the memory and the modem for data transmission? So of course, you can still say, they can steal the sensor, but like if people see the solar panel, this is the first thing they will attack. But if there is no solar panel, they are less, let's say, it will attract less attention to them. And actually, this is an example from Rwanda. As an option, we offer the possibility to install a camera. So you can see the camera is pointing to the riverbank. So if someone is approaching, they will take a picture. Maybe this is a deterrent, maybe not. That's up to you. That's up to your own country. You know your people better than me. But as another example, let's say you can install it on a bridge. You can install it with the arm. What about if you don't have all of this? This is like from the rainforest in Colombia. You can install the sensor on a cable. And I can tell you, I've never been over there, but I saw some cool picture. They took the instrument over there with a mule. So another feature that you have with our technology, you can have remote access. So you do not, and I know with the Met service, I think you need to send the technicians to do maintenance, to do calibration on the field. What about if I tell you you can remotely access from your office, or even technically can from Austria or Germany? This saves time, and time is money nowadays, right? And also, again, I would like to underline, this is about flexibility. You do not have a bridge, you do not have arm, you can put it on a cable. That's an example from Sedach area. Okay, in this case, they want the solar panel. So we have this, we generally joking at the summer, like we call it like a tank, so we have this design, highly reinforced and so on, which protect the switch cabinet, which is the second part that generally people attack when there is vandalism, and then the solar panel is protected, okay? And as you can see, like you can use satellite data transmission, 2G, 3G, 4G network connection. So it's really up to you, okay? No, sorry, because I was waiting for the animation, but that didn't work. Those are actually the data from that station. So this gives you an example about the flexibility on the sensor. So you can see here, actually it's going up and down. I will explain why, because it's downstream of a dam. So dam is using less and more water. So over here, we're speaking about an average of 300 cubic meter per second. And this one you can see is about 2,000 cubic meter per second. This same site. And this was all real-time data. They're transmitting data each 10 or 15 minutes. I cannot remember, but that's up to you how frequently you want to receive it. And then you will have it. And I want to remind you again, the study by the NOAA in terms like we are going to measure also velocity. I will keep it quick as I promised, so skip this one. So as you can see, we work worldwide. So why? Because probably you already have water level sensor. What we are offering, what we develop, what we are manufacturing is non-contact flow meter, which will give you, is not said by me. We have all the customers saying this is actually, our RQ is the standard in many countries, like probably you also know USGS from North America. That's the standard over there, for example, is the standard in Japan and other countries in Europe, okay? So first of all, you can see first point, you will be able to detect and alert your population earlier, okay? It's maintenance free, so you will install it. You do not have to invest money along the years. We still have like our sensor from the first series installed and still working. It's easy, really easy and fast to install. And then you can install it on a bridge, on a cable, on arm. So you have actually a really big flexibility in terms of installation. I give it shorter as promised, so thank you. If you have more questions, just come at my booth and I will be super happy to show you the equipment and answer to all your questions. Thank you.
Thank you very much, Luca. And now it's Jan for Brownie Designs.
Thank you.
Yeah. Let me just check on this one.
Oh, sorry. Very good.
Hello, everybody. Thank you, Luca, for a great presentation. And I'm Jan Barani. I'm going to talk about some advances in environmental monitoring for low maintenance, tightly conforming meteorological networks. As we heard over the past few days, right? How was it said? Africa is the supermarket for natural disasters, right? So we know this is actually happening everywhere in the world. Extreme events are becoming more and more common. And the best way to protect people, crops, and then anybody is to have accurate weather forecasts. But to have accurate weather forecasts, which give enough time for people to evacuate or to do damage prevention measures, you need to have accurate measurements that are sustainable. For that, you need sustainable meteorological networks. So, and this has been the issue from what we heard in Africa. Actually, it's an issue all over the world, where the maintenance of the networks is the #1 cause of insufficient meteorological data in many places around the world. There are a few factors. Young people, they don't stay at jobs long enough to become experts. It's very complicated to configure weather stations with data loggers and special sensors from different manufacturers, which have different protocols. And this is one of the things that we try to address. We used to make big weather stations also. And then at some point, about 2018, we decided, let's take a big weather station and shrink it. Shrinking down the weather station was not only had the benefit of making it simple to use, but also cut the cost down. Because suddenly you don't need any solar panels, suddenly you don't need any electronics. Everything scales down nicely, but you can't scale it too much because then your measurements are not good. Then you have to divide it up into certain parts, because a weather sensor, wind sensor, you need up high, 10 meters high. Measuring wind sensor and all one weather station at 2 meters. If whoever's seen wind data knows it's all turbulence, right? But you want to measure temperature, humidity, pressure at 2 meters. Rain, you want to measure close to the ground, where there is low wind, so we get good data. And minimizing service and minimizing costs of networks is a circular problem. To minimize service and field time, we require weather stations or equipment that requires minimal training to maintain. You also require sensors that are interchangeable. So in the field, you have to spend very little time. Ideally, if you can get the service technician to be in the field, their maintenance to be there less than an hour, 15 minutes. You can serve as many stations in one day, and you don't need many technicians. And you keep the cost down because people are the biggest cost of running any meteorological network. The other issue is the sensors should be as much maintenance-free as possible. But as we all know, apart from the radar sensors, which are actually maintenance-free, that Luca said, other sensors like rain gauges or any other temperature humidity sensors do require maintenance, but the trick is to make it as maintenance-free as possible. Here's an example of our rain gauge after 2 years at a farm. Somewhere in Europe, I don't know, Slovakia or Germany, came back to us and had 1 centimeter of dirt at the bottom of the funnel. The rain went slower to the funnel, of course, but it went through, worked still, and it was still within 3% of the original calibration. So I think that's something that hasn't really been around the meteorological world until now. We do test our devices everywhere. We just put them on high mountains, on snow, ice, which, you know, in Africa there are only a few places, but it tests the robustness. We also tested, we have the devices in Death Valley, USA, which is supposedly the hottest place on Earth, 50-degree temperatures. And they've been there for multiple years now. And one of the things that these devices enable people to do is to place them where you were not able to place a weather station before. So let's say for flood warnings or drought warnings, many places had high mountains where you can't place weather stations, or you weren't able to. But those are critical places where either snow gathers so that in the summer it melts and creates water flows, so you don't have droughts in the summer. Or where when fronts come, they dump a lot of rain in these places. And there are no measurements to see how much rain was accumulated, which will later in a few days or a few weeks come down and create water flows, which keep crops alive, people alive, and the water cycle moving. So basically, the accuracy of the sensors is also very important when it comes down to them having an interchangeable, so that maintenance tasks are very quick in the field. Accuracy is important because when you change one sensor for another after 2 years or 1 year, you don't want the old sensor to have drifted far and then suddenly you put a new sensor there and you get a big offset in temperature or humidity, because the old sensor was already dirty and produced inaccurate results. We've seen also due to this. Also due to the accuracy of sensors and having consistent measurements year to year, in Europe, we've seen improvements in weather forecasting of 3 degrees Celsius for frost warnings, which happened in Northern Africa, also Morocco, with customers there. And that's a huge increase in accuracy. When you're able to have a sensor on the site in the microclimate and map the actual simulation results from all the weather forecasting models down to the place where people read the data. It takes about 18 months or more to actually map models using MOS forecasts to actual weather station data and locations. But for that time period, you need to have consistent data. If you don't have data, you cannot really map very well the forecasts to give accurate forecasts for prevention. To give an idea of kind of what we've developed, yesterday, whoever was yesterday at night present here outside, we mounted a weather station and we had people throw huge candles at it to see if they could damage it. You can come see the results in our booth. Some people are laughing. They saw it. Basically, I think they can attest to the robustness. Oklahoma Met Office also gave us a nice quote on the left after a hailstorm that our sensors show no damage. And from Met Office in Austria, which is a pretty conservative Met Office, as far as our measurement performance, they gave us a nice quote in December, right before Christmas, which kind of makes your heart tickle, or however you say it. But let me get to the maintenance model, which is the most important thing to understand, and how the weather station maintenance models can change to make the networks, weather networks, affordable and sustainable, unlimited resources. So in Germany, we have a big network with the agro insurance. And the model hasn't been tested. And basically, all it involves is you have these weather stations at 5 places, 1 to 5, right? And you have some extra hardware that you buy, and then the technicians take the new hardware. They go to the place, they just exchange sensor for sensor, and then on their phone they just change the serial numbers, right? And on the data side, the photo side, data flips from one sensor to the other, and then they take the soil sensor after 2 years. We take it to the laboratory or to their Met Office. There they can clean the filter cap, calibrate the sensor head, change it, whatever they need to do. And then they can take that sensor to another location and flip it, take the service sensor and take the other soil sensor and exchange it like this. If you have multiple extra sensors, then you can do this very quickly, and you can do multiple services in 1 day very quickly with very small technical team. Because all it takes is 15 minutes, as people saw yesterday, to demount and mount the weather station. Antenna, everything, a battery is hidden inside, solar powered, 4 months of battery life. So the weather station is actually sending data while the technician is coming from the office to the field. So you know it was working, so you don't get into the situation where you get to the field and something doesn't work. You know, when you left with the weather station in the bed of the pickup truck, it was sending data. So the only thing that can happen in the field is that you don't have wireless coverage. And so with this model, you can very effectively and very affordably with actually unskilled labor, with students with a screwdriver to do maintenance on weather stations. All they need is a cell phone, where you have a level meter, so you can mount it left, so you know they leveled it, they take a picture, and you have traceability that they actually did the service. And so that's kind of the new thing that we bring to the meteorological world. We do have a portal, it's kind of cool, it's basically middleware. So for displaying data, collecting data, it's free to use with our sensors. And basically you can forward data to your specific applications to your meteorological software. Or you can actually connect the devices, if you want, directly to your, bypassing our portal, to your Met Office applications. So you have full flexibility in this. We leave it open because I think, every, hydrologist had their own software, meteorologists had their own software. Then you want, agricultural application have their own software. If one company to do everything is basically impossible to do well. So we focus on the middleware, the hardware, and let the end users do their end applications and build up forecasts or whatever on top of the data. Here are some technologies, new sensors that are up and coming that we're developing. We are developing a small water level sensor, quite different from what Luca was offering. This is going to be a simple, just a water level sensor for many hydrological applications for monitoring. But it's going to be wireless and it's going to be part of the whole sensor suite so that hydrologists can have, let's say, data on water level of creeks or reservoirs, small reservoirs. And it has to be affordable so that you can build larger networks with it. And it has to be basically maintenance free also, just about. We have some wireless rain gauges. We already have one, but we are doing an update, and there's a 200 centimeter one, with a bigger 400 centimeter squared one, 1 resolution. We have a black globe temperature sensor. A lot of heat stress is causing, in the summers now. People to go to the hospitals needlessly because there are no warnings about urban islands leading up or workers being in extreme temperatures and causing strokes and deaths, especially for the older population. And then we have for small airports, we are doing some METARs, auto METAR weather stations, so that small airstrips can have actual data that is accurate to WMO standards and ICAO standards, but is affordable, and they don't need to dig wires into the ground. It can be wireless, so you can put it at any airport, and it will generate auto METAR, or you can have actually a person supervise and create METAR out of it, verifying the data. So. These are the things we're working on and will be coming out in the next months or a year. And basically, what we are doing is trying to create WMO quality data to make it accessible everywhere and to make it sustainable, which is the most important part, to make sure that the networks can be maintained easily, especially in the current way like I said, the young people work, they change jobs every few years. They never have enough time to pick up the specific training needed for the big weather station maintenance. We already have weather stations all over Africa, all over the world. We have mostly in Europe, but we do have them all over the world. Although on the map, you can't see the African ones because they are through some nonprofits. We have a Liba National Park in Kenya. ICTP Institute has put them in Ghana, in Zimbabwe, Mozambique. Nigeria, we have a bunch of weather stations, and we are growing, and basically we are here to kind of open up the possibilities for you guys to get WMO quality data everywhere where it wasn't possible before. Thank you very much. I do have some extra slides if you guys want later on if you want to download the presentation. I won't go into it to keep the presentation short, but they are bird friendly as the weather stations.
Perfect.
So thank you very much, and if you have any questions, please feel free. And in the country. Thank you.
Thanks.
Many thanks, yeah, that was wonderful. Okay, one more presentation before lunch. Paul from Gannett.
No problem.
Good morning, good afternoon. So I'm the last one from this technical session, so cope with me a little before lunch. My name is Paul Malcolmus. I'm the CEO of GAMIC. We are a radar manufacturer out of Germany. And so I'd like to present you shortly the company, tell you a little bit about the differences between the frequencies of radar systems and explain where X-band radars can have their advantage or could be used in comparison to C-band and S-band radars. And show you a couple of applications that we have provided in that regard. So, as I said, we're based in Germany, close to the Belgian and the Dutch border. The company is more than 30 years old now, and we've been doing weather radar technology over the last 35 years. We're ISO 9001, 40001 certified, all our equipment is CE approved. We deliver our equipment also to armed forces and have a like number, so we, let's say, have a full certification for our systems. We're not very present in Africa. This is why I'm here. Well, we are here. So we are expanding our network with local partners in order really to make sure that if we have the possibility and the opportunity to supply radar, that we don't not only supply radar, but make sure that the system is well supported and maintained with our remote support to our local partners. We've had experiences in similar, let's say, environments. We're very active in South America and Southeast Asia and then in India. So I'm not saying it's the same in Africa, but at least the environmental conditions are quite close to what you could find here on the African continent. We are a manufacturer, which means that we develop our systems throughout our history, and we continue to do so. So I'm not entering in all the details. The slides will be available for download, or I can go more into detail at our booth. But basically, we come from the signal processing software side. We've been providing our technologies to radar manufacturers since the late 80s. And we started building our own weather radars about 14 years ago, focusing only on X-band radar systems. So this is our portfolio. We manufacture weather radars, ocean wave sensing radars, digital receivers, signal processor software that we use in our own system and that we provide to C-band and S-band weather radar manufacturers. We have signal weather channel extractors or ATC radars, and we build a customer solution for our customers. Our radar systems have a magnetron transmitter technology, solid state transmitter technology, basically state of the art, using a same base that we provide also to other radar manufacturers. I'm pretty sure all of you know what a radar is, how it works, but just to try to explain the differences of X-band radars to others, I just want to go a little into a theory. So a radar system is a remote sensing device sending out an electromagnetic signal and then receiving basically the echoes of the different hydrometers that are in the atmosphere. Don't get knocked out. This is, might look a little complex, but it's not that much. So how do you measure the performance of a radio radar? Basically, the performance of a radar is its sensitivity over range, meaning how much can the system detect over the distance from its location. And so we, as a radar manufacturer, use that complex looking formula, which is actually describing the power of the received signal in relationship to the transmitted power. So our job is to build a radar that is as good as possible in this part. All the other parts are independent of the equipment. So when you put all that into numbers, you get a sensitivity curve. So everything which is above that curve is detectable by the radar system. Everything which is below is invisible for the system, either in reflectivity or converted into rain rates over the distance. So how do the frequencies affect these curves? So X-band radar is 9 gigahertz, C-band is 5 gigahertz, S-band 2 gigahertz. So you can see in the middle, the frequency is up to a power of 4. So an X-band radar actually at the same level of power, transmitted power, generates a return which is higher by the level of 4 compared to the other frequencies. The diameter of the antenna, the opening efficiency, is something which is important, of course. It's the bigger the antenna, twice the bigger it's the return of the signal. And we see that the transmitted pulse length is also affecting directly the power, return power. So when the pulses are larger, we get a higher return. There's something else which is impacting for X-band radars of all radar systems, which is the losses when a signal travels over the atmosphere. So we call that attenuation. And the X-band radar suffers the most attenuation through precipitation on atmosphere compared to C-band and S-band. So this limits basically the ranges of the system. And this is why I'm going to explain a little what the application of X-band radars are compared to S-band or C-bands. Another consideration, the size of the equipment is depending on the wavelength. So X-band is 3 centimeters, C-band is 5 centimeters, S-band is 10 centimeters wavelength. So this is directly affecting the size of the equipment. So if you want to have, for example, an antenna with the same gain, an X-band radar, and C-band and S-band radar, you increase the diameter dramatically. So X-band, it would be something like 1.8 meter for 40 dB gain. C-band, it's 3.2, and S-band is 6 meters. So the equipment gets bigger, of course, and the energy consumption is bigger, the infrastructure is more costly, and so on. Also, so traditionally, C-band, S-band radars are used to ensure coverage of the territory. And to do that, depending on the topography, you put these large radar systems on top of the mountain, which is the best thing to do if you want to ensure perfect coverage. The disadvantage is that everything which is below the altitude of the radar system goes unseen by the system. So basically, an X-band radar can complement an existing network of S-band, C-band radars by being able to detect rain, falls, precipitation at lower altitudes. Also, something we usually forget is that the Earth is round, and the propagation of the signal is straight. So when you look at the 400 kilometers range with an S-band radar, you end up measuring precipitation, which is at an altitude of 3-4 kilometers in height. So a lot of things go unseen, even if you have coverage of S-band radars overlapping at the end of the range. So X-band radars can come in there as a cheaper solution in order to really guarantee the measuring or remote sensing of precipitation down to 1 mile, which is something the WMO is currently suggesting to do. So in summary, basically, an X-band radar is cheaper because it's smaller than an S-band C-band radar, and so you can, for the price of one large system, install 2 or 3 radars as a network, have a multi-radar detection, multi-Doppler measurements, and it's actually, I'm not explaining that X-band radar is the perfect solution, but it's an ideal solution to complement existing networks. So basically, where are X-band radars used? Hydrology, agriculture, mining, city warning systems, airports, every application which basically needs high accuracies and short ranges. Some examples we've provided over the last couple of years. This is a radar system operated by the Technical University of Berlin. It's an institute of urban climatology using the radar data over the territory of the city of Berlin, studying the impact of urban infrastructure on the atmospheric changes. This is a radar system that we operate together with our partner company Distance in our hometown Aachen. It's has been set up and in order to help cities to adapt to climate change. So the information is generated over the basically the limits of the city, and helping the city administration to take decisions with more precision than with the information from the German Weather Service they have previously, or as complement to that. This is a radar system in northeastern Brazil, installed for a private company, a mining company. This is an application which happens quite often. You have important operations of private companies or also of governmental institutions with little remote sensing data. And so in this case, the operations had to stop when there was a risk of lightning strike, risk of heavy precipitation. Installing that radar, the company was able to increase the production by 9.5 hours a week, and just for the story, half an hour of production of that open pit mine paid twice a radar system, so quite a good return on investment. These systems are small, X-band radars that can be transportable or mobile. This is an example of a radar system used by the Laboratory of Atmospheric Research of Cyclones of the island of La Réunion. The system has operated 1 year on the island of La Réunion, another year on the Seychelles, and then 3 months in Madagascar, helping the researchers better understand the precipitation generation and cyclones traveling through the Indian Oceans. That's something which was talked about beginning of the sessions yesterday. Population protection, an example here in Brazil, in the city of Niterói, the radar provides information specifically for the city of Niterói, covering a blind zone in the network, and is used mostly for warning of the population and the analysis of landslides risks, which is an important issue in that region. Flood control offices use radar systems. This is a system we provided to South Korea, which is dedicated to river basin and provides information for hydrological forecasts in that region. Finally, another mobile system which is used in France, Sweden, Brazil, Seychelles, and Canada, provided that for the French National Center for Space Studies. This radar system provides precipitation measurement before the launching of stratospheric balloons, which are very sensitive to humidity. Very quickly, the radar system is compact. There's not a lot of IT infrastructure. There's a lot of software information, software functionalities, which I'm happy to explain at the booth. with a lot of different products that would be of your interest on the hydrological agriculture, tracking, forecasting, warnings of severe weather that is generated by a radar system. And all this information can then be continued to a general decision-making system, which is a topic my colleague Helmut Wunstein will present this afternoon. It's easily put into data visualization, data gathering, collecting system, and then providing possibilities to really take a decision for an institution or private company. With also possibilities of having not only the historical data, but some nowcasting in the future. So thank you very much for your attention. Shortly before lunch, I hope I got you hungry a little. If you're still hungry after that, and I'll be happy to answer any questions you have on the other side. Thank you very much.
Many thanks, Paul, really appreciate that.